Solving linear inequalities. Solving linear inequalities. In one variable. We solve equations in one variable. Inequalities, we need to become familiar with some symbols here. Is less than. This one is greater than. Sometimes you'll see this one is less than or equal to. Is greater than or equal. Okay. Not only do you need to feel comfortable reading those symbols properly, you need to know how to represent them on a number line. We've used symbols for equation, for instance, on a number line. So we're going to graph some inequalities on a number line. Now, I'm going to start with an equation. If I ask you to graph x equals 3 on a number line, what that looks like is, here's 0. By the way, when I give you an inequality or an equation, you do not have to write every single tally mark. You just tell me where is 0 and where's the number that you're looking for. 3, just put it on the right side of 0 and we'll be okay. You don't have to write 1, 2, 3, especially if I have x equals 18. I don't want you to draw 18 little marks or 27. Just tell me, here's 0, 18 will be somewhere over here, and that's good enough. Now, to indicate that the value of x is a specific number, we put a dot on the number, like this. Okay? Now, how do we indicate that x can be greater than or equal to a number? So, you tell me where 0 is, right? You find the number in question, 3. Now let's think about this for a moment. Is the number 3 greater than or equal to 3? It's equal to, right? It is not greater, but it is equal to. And since the word here we're using is or, the number 3 satisfies this inequality because 3 is greater than or equal to 3. It's not greater, but it is equal. And because it says it has to be greater than or equal to it, then 3 works. That means that 3 is part of my solution.
But what about the other one that says less than or equal to?
So it could also be, in a moment I'll do the less than or equal to 3, and then we'll see that 3 works for both. Now what about a number like 3.1?
That word greater.
What about, it's not equal to 3, but it's greater than 3. In other words, to which side of 3 are we going to find the numbers that are greater than 3? I already know where the number that's equal to 3 is. It's right there. I want all the numbers to the right, so what I do, I shade the number line. I shade the number line to the right, and that's what my graph looks like. I put a dot to say include the 3, and shade all the numbers to the right of 3. If I'll tell you, no, it's asking, what if we have the less than or equal to? Is 3 a solution to this inequality? Yes. 3 is not less than 3, but it is equal to 3. That means that I get to put a little dot on 3 again. There's the 3. But this time I'm going to be shading the numbers that are less than 3, which means that I'm going to shade to the left of 3. Yeah, it goes, the number -1, -2, -3, they also, all of those numbers are less than 3. if I want the numbers that are greater than 3? Well, the first thing we're going to point out, right, is that 3 no longer works. 3.1 works because 3.1 is greater than 3, but 3 doesn't work. 3.01, 3.001 works. Any number that's bigger than 3 works, but 3 itself doesn't work. So we need a symbol to indicate we can get as close to 3 as we want, we just cannot have 3 itself. Yes, Joseph, what do you think?
So wouldn't it be like an open circle?
We're going to use open circles for that. There's different ways to show that, but in your book we're going to use an open circle. So when you don't want to include the number itself, we put an open circle on that number to indicate exclude the 3. Don't include the 3, but you can get as close to it as you want. And all you have to do now is select the one side of that point to shade. Since we want the numbers that are greater than 3, we're going to shade to the
Right.
right. Okay. And as you can imagine, x is less than 3. You have to identify your boundary point, which is 3. You have to decide, am I going to use a closed circle or an open circle? That depends if you want to include it or you want to exclude it. In this case, do we want to include or exclude the 3? Exclude it. So what type of circle? Open circle. And then you shade to the left. Now, when you solved equations in the past, I told you that it doesn't matter whether you write your answer as x equals 3 or 3 equals x. We've never had an issue with that. I promise you that with inequalities, if you don't learn to keep the x on the left-hand side, you're going to make mistakes when you graph it. It's going to happen invariably to a large number of you. So for that reason, I'm just going to make the following note. You can always rearrange an inequality that is written like this. If you have something like 5 is less than x, if that's your answer to a problem, my advice to you is before you try to graph it, rewrite it. If 5 is less than x, what can I say about x? X has to be greater than 5. Write it this way. Trust me on this. When you're shading, if you try to graph this one, many of you, even though you're conscious, I'm telling you right now that you make that mistake, you want to shade to the left because you see the less than sign right here. Always write the variable on the left-hand side. Always write the variable on the left-hand side for your final answer. Okay? So tell me how you can rewrite this one here. How would you rewrite this problem? 3 is greater than or equal to x. What's another way of saying that? X is less than or equal to 3. Does that make sense? If you reverse the x on the number, you also have to reverse the inequality. If this number is bigger than this number, then this number is less than this number. That's what I wanted to show you.